Hi, this is Sandra Webster. This video is going to give you an example of how to do a two-factor between subjects analysis of variance with SPSS, and I'm using the social distancing attitude study for the example. The hypotheses for this study, which we just completed data collection from, is that priming may change college students' attitudes towards the impact of social distancing. And in particular, listing advantages may lead to more positive attitudes, listing impacts may lead to intermediate or more negative attitudes, and listing disadvantages may lead to more negative attitudes. So basically, the first question in a survey is to list the advantages, 3 of them, or impacts, 3 of them, or disadvantages of social distancing during the COVID-19 pandemic. The priming manipulation may work differently for men than for women, and that's the interaction hypothesis. The variables basically are the independent variable, randomly assigned. Participants did one of the 3 conditions, wrote about advantages, impact, or disadvantage. We have a subject variable, which is gender, women and men, and we have one dependent variable for this example, and that is the overall positive attitude. And it's a composite of 46 attitude items. Half of them were negatively worded, and those were reverse scored before the composite was formed. This is the results, but let me switch over to SPSS and the data. The data is a very large set, and we're not going to look at all of those things today, but this is the way the SPSS data is set up. And so today, notice first of all that I've got treatment, and under values I have 3 different values. So these are the 3 conditions. Then it took me a long time to put gender down here because gender was an open-ended question. So it was a string variable, but I used a gender code based on that string variable, 1 for female, 2 for male. And the other variable is the positive attitude variable, and it was computed from all of the many attitude items. So this is the variable view. An important thing to notice is that variables that we're going to analyze with an Anova need to be numeric. The data view, what they wrote for their advantages, going through all those different things. So basically the data is set up so that we have all the information from a single case in one row, and all the variables are separate columns. I'm going to use an analyze, general linear model, univariate, because I'm analyzing one dependent variable at a time. Now, my variables come from an online survey. It's got the whole question is variable labels. I just want the variable names. It's a lot easier for me to look at them, so I just switch that. If I go all the way to the bottom, positive attitude is what I'm calling the overall positive attitude. Then I have fixed factors, and for this experiment, treatment and gender. I could put these alphabetical there in the order that I put them in when I collected the data. Random factors do not apply for this type of analysis. This would be something that we could use if the number code for the variable, the independent variable, was an actual quantity. So perhaps something like drug dose or something like that. But generally you can't use a random factor. You have to use a fixed factor, which basically means that you've got numbers here, but they mean categories. We're not doing an analysis of covariance, and we're not going to do a weighting. So these bottom 3 boxes you can ignore. But under options, we need to pick descriptive statistics and the estimates of effect size. Then I'm going to also ask for expected means, and I'm going to use treatment for that because I have 3 treatments. And so just because it's different doesn't mean if I get a significant F, I don't know which of the three are different. And it's the least significance difference test that I'm going to use. And I'm going to get a graph. I'm going to put treatment on the horizontal axis and get gender code for separate. I'm going to add it. I'm going to keep it as a line chart for now. And that's all that I'm going to ask for on all these options that I have. The dependent variable, positive attitude, the two independent variables, the treatment, and the gender code. So then say OK. Now I have to switch over to the output window. Make it large screen. First, we have our design with our N. We started off with 266 participants, but this particular analysis can only include those who gave us answers to the gender question. So that reduced the N somewhat. So you can see how they were distributed between the three treatment conditions and the two genders. Next, I have the descriptive statistics, the averages on the positive attitude variable, the standard deviation, and the N. At the bottom is the total. So if you wanted to look at the overall total. And then I have my test of between subjects effects. This is an analysis of variance for between subjects, and so all of the information is here. The first two are basically about the overall model, and they don't answer the hypothesis. Treatment is the main effect of the treatment. With 2 and 250 degrees of freedom, the F is just a 0.276. This is tiny. The probability of getting this by chance alone is extremely high. It is not statistically significant. Gender also has an F that is not statistically significant. 1 degree of freedom for the numerator and 250 for the denominator. However, the treatment by gender code interaction with an F of 3.926 with 2 and 250 degrees of freedom is significant with P equal to 0.021. So the analysis of variance tells us that neither main effect was significant, but the interaction was. So if I move down to the graph, this is what the interaction looks like. Now, a line graph is somewhat difficult to look at, but when the lines are not parallel, that's telling you that you have an interaction. And I'm going to switch to my PowerPoint again after I've looked at this to show you a different way of looking at these graphs. But basically, my hypothesis was that people would have a more positive attitude in advantages if they wrote about them. Well, not really. It looks like for the women, they were most positive when they wrote about impact, least positive when they wrote about disadvantage, and that was good. But for the men, I've got this boomerang effect. Impacts and advantages are not positive at all, but the disadvantaged group is significantly more positive. And so we need to be able to look to the theory and the data to try to understand what's going on with that. So on this slide, I have basically cut out of the SPSS output the main things that I need. The descriptive statistics here are showing us the same things as these graphs. Here's the analysis of variance summary table that I just went over. What I want to point out is that it's easier to interpret graphs sometimes depending on how you put them. These are the same graphs. It's just that this one is advantages by gender. The bottom one is gender by advantages. It's easier to look and see what's going on with the women if you want to compare women in the advantages, impact, and disadvantages group at the bottom than to look up here. And it's easier to compare gender effects if you want to look at, well, within disadvantages, were the men higher than the women? And these are 95% confidence intervals, so they're useful for us to interpret this data. So that is an example of a two-factor between subjects analysis of variance using SPSS.